Our assessing learning goals 1, 2, 3, 4, 6, and 7. Would you like to read the problem?
Okay, so we did quest problems 12 and 13, and it involves a box moving down an incline, and at the top it's frictionless, and at the top so it starts at rest at the top, and then it moves down, and then the spring keeps it from moving down any farther. So the spring goes from unstretched to stretched. And as you can see, our LOL diagrams in the top right, we have the box, the ramp, the spring, and the earth. And then in the beginning, it's at the top, and the spring is unstretched, so there's potential energy. And then once it goes down, the spring gets stretched out, and there's less potential energy, so the energy transfers from potential to the spring. So that gives us our equation where the initial UG equals the final, which is US. So UG, the potential energy we solved, was mgy, and you get the y value by doing m times g times change in x sine theta, because the change in x is actually when you do a triangle of the movement. Change in x is the hypotenuse, and then you do sine theta, which is 29 degrees, to find the height, the opposite length, which is the height. So mg sine theta equals the spring equation, which is 1/2 kx, k change in x squared. So
what we did here, we solved for x, or the change of x, and we got 2 mg sine theta over k equals x. And we plugged in, we got 2 times 6.82, which is the mass, mg, times gravity, times sine 29, over the force of the spring, 298 newtons, and we got 0.2175 meters.
Yeah, so at the bottom, the k is the spring constant, and basically we took this equation at the top, divided by x to get rid of the x squared, and then divided by k, so 2mg sine theta over k. You can plug those numbers in; they're given to you, and then you get 2.2. We got with our numbers we got 0.2175 meters. That's our change in x. That's how far it moves down the incline. And then question 13 asks, what is if positive direction is up the incline, what is the acceleration at the bottom, at the end? So we did our F-net equation, and the only two forces acting on it are gravity and the spring. So gravity, we found in the free body diagram, we found this Wx value. So we did mg times sine theta, which is 29, and then for the spring formula is negative kx. So we just subtracted those two together, equals ma. So that's the F-net equation. And then to solve it, we just divided by m to get gravity times sine theta minus kx over m equals acceleration. So gravity 9.8, sine theta, we got 29, that's our angle measure. You can plug that in your own angle measure. Minus k, which is the spring constant, ours was 298, times change in x, which we found was the answer to number 12, over the mass. Our mass was 6.82. You can plug that in, it's your own mass. And then that all solves out to be negative 4.75 meters a second squared.
Acceleration. Thank you for watching today's video. Come again.
And that's it.